Hi, this is Sonia Doucette. In this video, I'm going to show you how to calculate among moles and grams of reactants and products. So the balanced chemical equation that we'll use for all three problems, there's a part A, B, and C for this one, is shown at the top there. So the first problem says how many moles of hydrochloric acid are produced when 1.85 grams of methane gas react. So what you're assuming here is that you have 1.85 grams of one of the reactants, methane, and that the amount of chlorine gas, Cl2, is present in unlimited quantities for this type of problem. So you start with what you know. You know you have 1.85 grams of methane gas. And in order to figure out how many moles of hydrochloric acid are produced, so hydrochloric acid is one of the products, you have to be able to relate moles of hydrochloric acid to moles of methane. You have to relate everything through moles, whether it's within a chemical formula or within a chemical equation, as we're going to do here with reaction stoichiometry. So in order to do that, you have to get from grams of methane to moles of methane first, and then you can relate moles of methane to moles of hydrochloric acid. So you know grams of methane, and you can find the molar mass of methane by looking up the weight of carbon and hydrogen in the periodic table. So you'd have that many grams of methane once you do the math there to 1 mole of methane. And then you're going to then relate moles of methane to moles of hydrochloric acid. So you can look at the reaction stoichiometry and see that for every 2 moles of hydrochloric acid, you have 1 mole of methane. So if there's nothing written in front of a reactant or product in a balanced chemical equation, the coefficient is implied as 1. So what you can say is that for every mole, for 1 mole of methane, you're going to have 2 moles of hydrochloric acid. So that relationship comes through the reaction stoichiometry. And then your moles of methane cancel, grams of methane cancel, and you're left with moles of hydrochloric acid, which is what you're asked to solve for in this problem. So when you do the math there, you'll get 0.231 moles of hydrochloric acid. So that's your answer for part A. Part B says how many grams of chlorine gas are needed to produce 2.42 grams of hydrochloric acid. So you want to do something similar here where you're going to relate grams of chlorine to grams of hydrochloric acid by converting both of them into moles. So you can start with what you know. You know you have 2.42 grams of hydrochloric acid. And then you can get to moles of hydrochloric acid by taking the molar mass of hydrochloric acid, which is going to be the atomic mass of hydrogen plus the atomic mass of chlorine. So that's how many grams of hydrochloric acid you have per 1 mole of hydrochloric acid. And then you can relate moles of chlorine to moles of hydrochloric acid. So if you go back up and look at the chemical equation, you can see that for every 2 moles of chlorine gas, you have 2 moles of hydrochloric acid. So that's going to be your relationship. 2 moles of hydrochloric acid to 2 moles of chlorine gas. And then the last thing you need to do here is take the molar mass of the chlorine gas, which is 35.45 times 2 grams of chlorine gas, and divide that into by 1 mole of chlorine. So if you go ahead and do the math there, what you're going to end up with is 4.71 grams of chlorine gas, and that is what you're asked to solve for. The final problem here says how many grams of chlorine gas are needed to react with 1.85 grams of methane. Similar, just like the previous problems. You're going to have to relate grams of chlorine gas and grams of methane through moles. So you want to start with what you know. You know you have 1.85 grams of methane, and you want to get to moles of methane. So in every 1 mole of methane, you're going to have 16.042 grams of methane. So that's just the molar mass that's calculated using values for the atomic mass of carbon and hydrogen from the periodic table. So I just, instead of writing it all out there, I've just pre-calculated it and plugged it into the equation. Okay, so now you want to relate moles of methane to moles of chlorine gas. So if you look back up at the stoichiometry to figure out how many moles of chlorine gas you have for every mole of methane. So let's look. So for every 1 mole of methane, we have 2 moles of chlorine gas. So let's go back down and plug that into our dimensional analysis here. For every 1 mole of methane, you have 2 moles of chlorine gas. And then the final step here is to get moles of chlorine gas into grams of chlorine gas. So using the molar mass of Cl2, which is 70.9 grams of chlorine per 1 mole of chlorine, we can get our answer here. So moles of chlorine cancels, moles of methane cancels, grams of methane cancels, and you're left with grams of chlorine, which is what you want, and you get 16.4 grams of chlorine. So we've all solved all parts of all of these problems. A couple different examples of how you convert among moles and grams when you're dealing with reactants and products in a balanced chemical equation.